So hello everyone, in this session we'll be learning about the software interrupt instruction. We have a very simple syntax for software interrupt instruction. There is one condition for this immediate value, that it can be max of 24-bit size. Now let's see what exactly is this instruction. A software interrupt instruction is nothing but an ARM instruction which is used to request a service from OS, that is operating system, or supervisor code. Okay, what is a supervisor code? Supervisor code is nothing but a program or a routine which is run in supervisor mode of ARM. Okay, we know there are total 7 modes in ARM, out of which 6 are privileged, 1 is non-privileged. Out of the 6 privileged mode, we have one of the modes called as supervisor mode. And whenever you run a software interrupt instruction, immediately there is a jump to supervisor mode. Okay, because the purpose of this particular instruction is to request any service from the OS. So I already told immediate value should be of 24 bits. Do you think there is any predefined set of values here, or you can choose any value? Actually, the immediate value chosen here is dependent upon the programmer. That is, this particular 24-bit value is programmer defined. Okay, in the code there is something called SWI handler. This is nothing but routine which is executed whenever a software interrupt instruction is seen. So this is the range of values programmer can select from 0 to FFF, okay, which totally comprises 24 bits. Okay, in the handler defined by the programmer, he can choose specific numbers to denote specific service. Okay, and then based on what service is defined, when you execute this particular instruction, that particular routine or that particular code will get executed and the desired result is obtained. So in short, there is no predefined immediate value provided by ARM. Instead, it is defined by the programmer in the SWI handler, and based on whatever is defined in the SWI handler, when this particular instruction is executed, that particular service or action is initiated. Now let us understand what happens when this particular instruction is executed. These are the changes that you observe. Okay, and all of these changes happen as an atomic operation. That is, as soon as this instruction is executed, you will see all of the steps are already carried out. Let's understand what are those changes. Okay, so loads SWI vector. What does this mean? PC will be updated with an address 0x8. Okay, that is because 8 is the vector address for SWI handler in case of LPC2148. This is one thing you should know. This is nothing but your vector table which shows what are the specific addresses which should be updated in PC whenever these exceptions are encountered. As you can see here, for SWI the address is 8. What it means is, whenever this particular instruction is executed, the address in PC is automatically changed to 8. Whereas if you notice the other cases, that is in case of reset, the address updated will be 0. Okay, so we'll not go in depth of these topics, but this is something you should know, that address 8 is associated with software interrupt instruction handler. Already we discussed that loading SWI vector in the sense PC is updated with address 0x8. The other things that we notice is the CPSR, whatever content is there, that is the current program status register content, is updated in the SPSR. And which SPSR should it be updated with? It will be updated in the SPSR of supervisor mode. Why exactly of supervisor mode? Because as soon as this instruction is executed, processor mode changes to supervisor mode. And along with that, IRQ that is interrupt request, is set as 1. Why is this the case? The interrupt request is set as 1 in order to disable any low priority interrupts, while FIQ will still be 0 because you are allowing any high priority interrupt. And one more thing you will notice is LR underscore SVC is updated with return address. Why exactly is this required? Let's assume you have executed some instruction like this. Okay, and this, let's assume, is some move operation which is supposed to be carried out after this particular step. Then the address of this particular instruction will be stored in the link register of supervisor mode. Okay, so these are the different changes you will observe, okay, as soon as you encounter an SWI or a software interrupt instruction.